Hello everyone, my name is AAldinger, and this is my final project demonstration for the course, Multi-Region Active Passive Disaster Recovery using Terraform and AWS. The core objective of this project was to deploy a highly available, fault-tolerant web application spanning two AWS regions. This ensures that if our primary region suffers a total outage, traffic automatically fails over to a passive backup region, minimizing downtime. Let's look at the high-level architecture. We have two key regions. First, our active primary region is US East 2 or Ohio. This is where our production environment lives. It's highly available, protected by an application load balancer or ALB and an auto scaling group or ASG. Second, our passive secondary region is US West 2, or Oregon. This is a simpler setup, hosting a static single EC2 instance ready to take over. The intelligence that connects these two regions is Route 53. Route 53 hosts our domain, www.alexicodes.com, and uses health checks to constantly monitor the health of the primary ALB. If that check fails, Route 53 automatically flips the switch and routes traffic to the secondary EC2 instance. Phase 1, Primary Infrastructure Deployment. Phase 1 focused on deploying the primary production stack entirely through Terraform. Let me walk you through the key files in the project folder, starting with the configuration. First, the provider's TF file. This is crucial for managing our multi-region deployment. We define the default provider targeting US East 2, which is our active region. Crucially, we also define a second provider block with the alias secondary, targeting US West 2. This alias is what allows us to manage two separate regions from a single Terraform configuration. Next, variables TF. This separates configurable settings from our infrastructure logic. This is where we defined our region-specific AMI ID for Amazon Linux 2023, and the domain name which we use to make the Route 53 configuration reusable. The heart of the project is main TF. This file orchestrates the entire production environment. In section 1, we define the VPC and networking setup. We create the VPC and the internet gateway. We then define two public subnets using a count loop to ensure they are deployed across different availability zones. This is fundamental for our high availability objective. In section 2, we set up the security group. The most important rule here is for the web server itself. We allow inbound HTTP access on port 80, but only from the application load balancer's security group ID. This prevents direct internet access to the EC2 instances, making the ALB the single secure entry point. Section 3 defines the auto scaling group, or ASG. The launch template specifies the instant details, including the necessary IAM role and the user data sh script we will run on boot. The ASG itself is configured with a min size and desired capacity of 1, meaning it will automatically replace any unhealthy instance, providing the core self-healing capability of our primary region. Finally, the user data sh script. This script installs Apache and crucially uses the instance metadata service to dynamically fetch the instance's private IP address and inject it into the index HTML page. We also set a specific region color, in this case blue, for quick visual confirmation. While executing the standard workflow, I encountered two significant environment roadblocks. The first was a basic dependency issue. Running Terraform init resulted in a ZSH command not found Terraform error. This was resolved by using Homebrew to install Terraform and updating my shell's path. As you can see here, while writing Terraform init, I get the command not found. Then I use this command right here to install Homebrew, which then allows me to install Terraform And as you can see here, it says Terraform has been successfully initialized. The second major hurdle, as you can see here, error, no valid credential sources found. To fix this, I had to generate programmatic credentials. This meant navigating in the AWS console to IAM, as you can see here. I click IAM, click on users. I select the user I've recently used, go to security credentials, scroll down, and I create access key. I then took the generated key and secret and used them to export them as environment variables in my terminal session. Only after this step did Terraform finally have the necessary permissions to communicate with AWS. With credentials sorted, the Terraform apply successfully provisioned all 18 resources. Let's verify the deployment in the AWS console, making sure the primary region is functioning. If we check the console, we can see all the defined components. The VPC is present, and under EC2, we see our application load balancer is active. The auto scaling group shows one running instance, and under its target group, that instance is marked healthy. The custom configured security group is also correctly attached to both the ALB and the EC2 instance. When we hit the ALB's DNS name, we see the welcome page for the primary region with the blue color, confirming our production environment is live and highly available. Secondary code walkthrough and deployment, US West 2. Moving to phase 2, we deployed the passive infrastructure in US West 2. This is defined in secondary infra.tf. Here, every resource block uses the provider AWS secondary argument, targeting the Oregon region. This infrastructure is simpler, just a VPC, a single EC2 instance, and an elastic IP. Its job is strictly to be a static fallback server. We hit a roadblock here with an invalid AMID malformed error. As AMIs are region specific, this fix was to manually source the correct ID for Oregon and update secondary variables.tf file. After that fix, the deployment was successful. In the Oregon console, we confirmed the single EC2 instance is running. Confirming the instance's direct public IP loads, the uniquely styled secondary region page with its distinct color, confirming our passive fallback is operational and ready. Phase 3, Route 53 Logic Walkthrough. Phase 3 introduced the critical failover logic defined in Route 53 TF. First, we create two Route 53 health checks. One monitors the primary ALB and the other monitors the secondary EC2 instance. Next, we define the two failover routing records. The primary record points to the ALB and is set to primary. The secondary record points to the EC2 IP and is set as secondary. This is the core logic that achieves our automated disaster recovery. In the Route 53 console, after updating the domain's name servers, both health checks currently show a healthy status. When we navigate to the live URL, alexicodes.com, we see the content served by the primary region. Now for the critical test, simulating a failure. Initially, simply stopping the instance failed because the auto-scaling group immediately replaced it. The necessary workaround was to temporarily edit the primary ASG and set both the minimum capacity and desired capacity to 0. This effectively disabled the auto-healing mechanism. With the ASG disabled, stopping the last instance successfully forced the ALB's health check to fail. As soon as the primary health check turned red in Route 53, the failover logic engaged. When I refresh the browser at alexicodes.com, we now immediately see the text, hello from the secondary region US West 2. This is the passive fallback server. This confirms the system automatically failed over to the passive endpoint. The restoration process was simple. We edited the primary ASG again, setting the capacity back to 1. Once the new instance launched and was verified as healthy, the Route 53 health check turned green, and traffic automatically switched back, or failbacked, to the primary region. In conclusion, this project successfully deployed a robust active-passive disaster recovery architecture across 2 AWS regions using Terraform for 100% infrastructure as code. All objectives, including high availability and automated failover via Route 53, were met and validated through simulated failure. The project provided excellent experience in not only deployment, but also essential troubleshooting of environment variables and the crucial interaction between services like the ASG and Route 53. Thank you for watching.